Hello, and welcome to the chapter on probability. First question for first thing about probability in this section is we're only going to do section parts of this first section 4.2. So we're calling it 4.2a, and then we're going to go to 4.2b and discuss that. So your homeworks will be short and quick and not a whole lot of math. And so therefore you only have a couple of days. So this first homework will be due on Wednesday. And then tomorrow we'll give you the other lesson and it'll be due Friday. Okay? All right, so I also gave you on the Google Classroom the notes for this section, 4.2 notes it's called. And 4.2a notes it's called. And I need you to print that out. I actually wrote out the answers for you so that if you don't listen to this too much, you can still figure out a lot of it. And this should help you with the first homework, but I'd like to go through it with you. So the idea, and then I'm going to give you some examples and talk about it up here. So the first thing we want to talk about are the three styles of different probabilities. There are three basic kinds, and we call them classical, experimental, and subjective. The classical, which I'll just call C, is the one that we do the most. An example is, if you know a deck of cards, what's the probability if I pick a card, I get the 5 of spades? Well, that's 1 out of 52. And if I roll a dice, which has 6 sides, actually it's called a die. The one is called a die. It has 6 sides. What's the probability that I get a 3? And you say 1 out of 6. Later on, we actually get into a little more complicated, which sounds silly, but things like, what's the probability if I have a deck of cards, I get a jack or a spade? That's actually section 4.3. And then we get even further and make it a little bit harder and say things like, what's the probability that if I deal 5 cards, I get what's called a royal straight flush? That's section 4.4, and that's where the fun begins, really. This is all just basic fundamentals approach here. So classical is actually the one we'll be doing the most. Then there's what we call experimental. Experimental is something you cannot say at the time. You know, what's the probability that if I take 17 dogs and I have them run a race, what's the probability that my dog will win? Well, it's 1 out of 17, but there might be more information. So we would run an experiment. You know, my dog might be 14 years old, so therefore it's not a very good probability and things like that. You have to conduct an experiment in order to know the probabilities of something happening. The last kind is called subjective. Subjective is exactly what it says. It's you make a shot in the dark. What's the probability a meteor will skyrocket through the earth and hit the earth? What's the probability, you know, you climb a tree and you see a cardinal or something? I mean, it's just things that are so subjective that you just say 1 in a million and be done with it. Things like that. So what is the definition of probability? So we write probability like this: P of X. And X is called the event. What is the probability that that event occurs? So if I had a deck of cards and I said, what's the probability of picking a 5? Okay, that would be 4 out of 52, which leads us to the definition of probability. So what is the probability's definition? I label it as the number of successes divided by the number of total outcomes. So it's a fraction. There are 4 5s and there are 52 cards. Pretty simple, pretty straightforward. A quick thing about this is that what can P of X fall between? Well, looking at this fraction, you can never have this numerator be larger than the denominator, because that means if you had a fraction like this, 5 out of 3, that means you had 5 successes, but you only tried 3 times. That doesn't make any sense. Therefore, this has to be less than or equal to 1. We're going to talk about the 1 in a second, but this can never be bigger than 1. What can be the smallest? Well, can you have a negative? Can this be a negative 4 out of 52? And the answer is no. So probabilities have to be between the 0 and 1. And we'll talk about both of those in a second. Okay? Oh, excuse me. I'm trying to do all these things here. So, next question. What is the law of large numbers? Well, let's say one of you decides that you've never played basketball and you go down and you shoot a free throw at the basketball and you make it. And we say you are the world's greatest free throw shooter because basically you're 1 out of 1, which makes it 100%. Well, that's not really true because it's too small of a data set. And so we have you shoot 1,000. And before you know it, your probability will go where it belongs. If you're a basketball player and you practice this all the time and you shoot 1,000, you will start to shoot the percentage that you shoot all the time, maybe 80%, things like that. If you've never played basketball and you don't understand and you'd have a terrible shot, then maybe your percentage will go to about 20%. So law of large numbers simply means the more times you try something, the more realistic is your probability. So let's talk about this really quick. What's it mean to have a 1? As a probability of 1 means it is going to happen every single time. What's the probability that Thanksgiving is on a Thursday? That's 100% of the time. What's the probability of 0? That means it will never happen. It will never happen. So that's what that means. Okay? The next thing we really want to talk about quickly is something called the complement. The complement of a probability. So the complement looks like this. The probability of A with a line over it. That means not A. So if the probability of picking a 5 is 4 out of 52, what's the probability of not picking a 5? Well, how many not 5s are there? There are 48 out of 52. So the question is there some kind of a math formula between these two? And the answer is sure. The probability of A plus the probability of not A is equal to 100%. Because this is you are successful, and this must mean you are a failure. And when you do all that, you get a 1. Okay? Rounding and reducing fractions, unless I tell you, please just leave it like this. Don't worry about dividing. If you do divide, round it to 3 decimal places. 3 decimal places. So if you end up with like this, 0.34796, round it to 0.348. The 9 makes the 7 and 8, and therefore that's 34.8%. Okay, so, and then our last question is, what makes a probability unusual? And this is where you will divide. To make a probability unusual, our probability has to be less than 5% or 0.05. So is it unlikely to get a 5, which was 4 out of 52? Well, do you know if that's less than 5%? I do not know. So I take my calculator and I divide. 4 divided by 52, and that's 0.077. That is not less than 5%, so therefore it is not unusual. Okay? All right, there's your lesson. There is a second page to the notes that I'm going to send you, but please, that was for a thing we were going to do in class, but we're not going to do it. So the homework's a little different than what's on the sheet, so please pay attention. It is on page, excuse me, I got the book here. 146 is where it starts, page 146. And I want you to do all of 1 through 10, all of those. Some of those are just very general questions that you just write an answer down. There's not much math. Some of it's even subjective. As long as you write an answer, I'm going to give you credit. And then 12 through 20, do the evens. That way you don't have to do all of them. 12 through 20 and stop right there. So this is due Wednesday at 3 o'clock. Wednesday at 3 o'clock, okay? All right, that's it. If you have any questions, please ask. All right, thank you. And we'll talk to you later. Let me learn how to click this off now. There I am. Hey. All right, here we go.